so in this video we're going to start doing the derivatives of trigonometry or trigonometric functions. So, you know, we have sine x. So if you have, let's just get right into it. If you have y equals sine x here, it's going to be, actually let me put it here, is going to be cos x. The derivative of sine x is cos x. So, you might wonder, what is the derivative of cos x? Well, you guessed it. Kinda. It's actually negative sine x. One thing to remember though, when you have sine x at face value, it is cos x. But we'll learn what to do when, you know, you have sine 2x or something. I'll get to that in a bit, but let's just try one. Say you have y equals cos 3x. Well, at that point, you're going to want to do the chain rule, where you have, let me just write it out, and you might actually just see what I'm talking about. Actually, this may be easier to do if I explain it to you like this. If you have y equals sine and then a function of any kind, then the derivative of that is going to be cos f of x, or whatever was in there, times the derivative of whatever is in that function. Similarly with this again, comes straight from the chain rule, where you do your internal function and then your external function. And there you go. So when we have something like, you know, y equals sine x squared, the derivative is going to be really just cos x squared times the derivative of what's in there, which is 2x. That's it. Similarly, if you have y equals sine squared x, then we can say that this is the same as sine x squared. And then we'll just use the chain rule, where we say u equals, u equals x squared and y equals sine u. So when you put that down, sine x. So that's what this is. So when you put this into the chain rule, then you're going to have dy over dx. The derivative will be which is, the derivative of this one, times cos x, which is the derivative of sine x, at which point u will become 2x squared cos x. Oh, sorry. This one's incorrect. Y equals oh no, I confused a lot of people. This is actually going to be y equals u squared, and u equals sine x. See, y equals, we're going to say u is the sine x, and y is equal to u squared. So the derivative of y is going to be 2u, as u squared becomes 2u. And then the derivative of sine x becomes cos x. Let's do another one. Let's do y is equal to cos of 1 plus x cubed. So let's start doing this one. Well, first, let's do the derivative of cos, which is going to be negative sine of 1 plus x cubed times the derivative of what's inside here, which will be 3x squared. Just simplify that. Negative 3x squared sine 1 plus x to the cube. And there you go. It's actually much easier than it looks. Say you have y equals e to the sine x plus cos x. Now let's do that. Remember our derivatives for exponential functions. You just rewrite the same thing. Sine x plus cos x times the derivative of the exponent, which is going to be sine x will become cos x, and we're adding cos x, but the derivative of cos x is negative sine x, so it's going to be, and there you go. It's just one step at a time. So before, I think I could add it to this video here. Obviously when we're talking about trigonometry, you cannot forget about tan x. So the derivative of tan x is actually sec squared x. Wow. Yeah, but I should clarify from that if you have y equals tan with a function here, then similarly the derivative of y with respect to x is going to be plus 3x, then you know your dy over dx is going to be x squared plus 3x times the derivative in there, 2x plus 3. Yep, that is correct. What else do we have? We can do another one. Say you have y equals sine x plus tan x all to the power of 4. Well, now we can do our chain rule. Bring the 4 down. Write this again. Tan x times the derivative of what's inside. The derivative of sine x is cos x, and the derivative of sine x is cos x, and the derivative of tan x we know is sec squared x. Simple as that. Let's try one more. Y is equal to, say, x tan of 2x minus 1. So here we have clearly the product rule that we're going to try. So let's do dy over dx, and let's do the derivative of the first value, which is 1, times plus the x times the derivative of tan x over this entire function. You know what, I'm going to write it here, plus x times, so the derivative of tan x is sec squared times 2x minus 1 times the derivative of what's inside, which is going to be 2. So now you can rewrite this as tan 2x minus 1 plus 2x sec squared 2x minus 1. And there you go. That's how easy the trig ones are. If you want to try one on your own, you can do y is equal to 3 sine 5x tan 5x and find out dy over dx. And then just throw that into the comment section when you're confident. And yeah, that's all for this video.